Hello everyone. If you have ever heard of some big data tools like Hadoop or Spark, but you don't know where to find the resources to practice them, then this video might be able to help you a little bit. And in this video, I'm gonna show you a demo on how we can use one of AWS services for big data called EMR. And I will walk you through some of the steps in order to set it up as well as try it out and to understand what AWS has to offer. And so let me start with the video. So first of all, you can navigate to AWS homepage. This is on my screen right now. And the first thing we do is we go to EMR, or you can search for it here. Then afterwards, you will be directed to a page for the console for this service, and you can interact with this service through AWS CLI or the SDK, or you can also use the UI directly. So for instance, we would like to create a cluster so that we can run big data tools like Hadoop and Spark on top of it. And you can click on this button for create cluster, and then you can decide what application bundle you want to include in your cluster, and AWS will take care of setting up the servers. Also make sure that all the configurations and libraries are set up so that we can use the tools directly, so you can skip the step of the setting up. And this is usually very useful for us who just want to practice using the tools instead of being concerned with all the DevOps or infra work. Yeah, so in this example here, you can see there are different application bundles like Spark, Core Hadoop, Flink, HBase. They are different big data tools, but in this video we're gonna use Spark, and there will also be Hadoop as well. And as you can see here, along with Hadoop, we will have Yarn and Zeppelin. So these are some of the nice tools that we can use to test out and analyze our data, for example. And that's basically one of the main things that we need to do in this setup. The next thing is just to configure your instances. So instances are virtual servers that AWS will provision for us the moment we create the cluster. And in each cluster in AWS for EMR service, we will have three kind of instance. The first one is primary, which is like a master node where we can access and to directly control our cluster, to interact with Hadoop file system, or to submit your Spark job. And the Spark job will then process your data or read data from Hadoop and write it back. Yeah. Besides from primary nodes, you also have core nodes. These nodes are like meant for both data storage and processing. So Hadoop can make use of it for block data storage and also for processing. Then we have task node. So these nodes do not store data, but they only help out when we need additional processing capability. Yeah. Besides from that, we can configure how many instances of each kind of nodes that we want. Some networking that I will not go through, but when you create your AWS account, you most likely have to do some setup with this, like creating your virtual private cloud and subnet. And then another important step is for you to set up a key pair so that you can use SSH to securely access the cluster, especially the primary node. So I've created a key pair here. You just need to do it when you set up your AWS account. There's even a create key pair button here, and then you include it here so that later we can use our shell or our terminal to access the cluster. And afterwards, you can choose some default role and default profile. Yeah, so that's basically the main step to create a cluster. Afterwards, you can click on create cluster. And here I have already created the cluster because it takes a while for AWS to provision everything and set up all the configurations and software. So then now we will directly go into analyzing and playing around with this cluster. Yeah, so we can click on it. I have also created a file including the steps that we can do to test in this demo. So the first step is already done. We have set up a basic EMR cluster, and our cluster setup is minimal, consisting of only one primary, one core, and one task. And then we can check to verify that our nodes have been created by checking all the EC2 instances. So EC2 are AWS service for virtual servers that I have talked about. So we can go to services and search for EC2, and as you can see, there will be in this case 3 active instances that has been triggered with the instance type that we have specified, and this shows that yeah, this is our elastic master and slave nodes. Okay, so after checking, the next thing we do is to make sure that we can access the cluster or the nodes. We can access all the nodes through SSH, but mainly we will use the master node. Yeah, so to double confirm that we can access the node, the first thing is we need to check our primary node security setting. So you can click on the primary node here under security groups firewall, click on this link, and make sure that in your inbound rules you can you have already included permission access for SSH type of access to the port 22. So this is the default port for SSH, and for the source IP you can use my IP. Okay, so after making sure that we have already allowed SSH access, we can try to do it here. So under cluster management, you can see that there is a connect to the primary node using SSH link. So clicking on it, you can see the command, and in my case I'm using Mac, so I can simply copy this command. Just make sure that I have my key pair ready on my local. So the next step we will do is to execute this command. So I will specify the path of my key pair here on my own file system, and after doing so, yeah, we can access the primary node of our cluster. So this is the main entry point where we will control the cluster, interact with Hadoop and Spark. The next thing that we will do is, let me double check. So we will then verify that the cluster has been set up. We will find our executables, our config, as well as installation. So make sure they are there. So our executable would likely be under user bin. Right. We can do ls user bin and Spark shell, for example. Yeah, so if you tap on Spark, you will see that we have the Spark shell or Spark submit. So Spark submit will be the executable for us to submit our Spark job. Spark shell is the interactive shell for us to interact with Spark directly without submitting a job, right? And next we will double check that all the configuration, if you want to manually configure them, and you can double check it here. yeah, you can see that the basic Spark config setup are already here, like the Spark environment or Spark defaults config. For the actual installation, we can find it somewhere here. Yeah, so you can find all the Spark examples or all the beans data, some sample data if you want to test and run it, or also yarn. Okay, then the next step we want to do is we want to be able to access some of the application user interface. So so some of the services like Spark or the Hadoop file system or Yarn have some UI that is hosted on our cluster as well, and we can access this UI to interact with them instead of the command line. So for instance, we have a UI to access the Hadoop distributed file system called HDFS here. So by clicking on this URL, you should be able to access it, but the issue with this is that we also need to enable SSH connection in order to access this endpoint. The reason is because all our services sit behind a private network. So we have to use one feature of SSH connection called, you can click on it where they will explain. It's called SSH tunneling with port forwarding. And we basically need to run this command to set up the SSH tunnel. And then, yeah, let me show it here. Run this command. Yeah, so it's already running. And then we will do some, we have to use a proxy management tool. So after running this command, all our requests, we want it to, all the requests that go to this endpoint, we want it to go to one of our local port. And to do so, we can set up this extension in Google Chrome called Switchy Omega Options. And basically we have to use a script here to find the proxy for the URL. So all the URL that match certain patterns like this, we will return our proxy, which we have already set up with SSH called socks, this socks here, and it will route the request to our localhost at port 8157, which we have specified previously. Yeah, right. So after this setup, you most likely will be able to access. Let me do a double check. Yep. So after this setup, you click on the link again. Is my proxy on? It should be on. Let me why is it not enabled? Oh, yeah, sorry for the issue. So basically I think I did some changes. So we need to select that proxy setting that we have configured previously, and you will be able to access HDFS, yeah, in this case. And if you click on resource manager, which is basically Yarn, you will be able to access the UI here. So let's do a check. This HDFS UI allow us as a to be like an admin role to have an overview of where are our data nodes, which are the nodes that store the data. We can see how much data is being stored. Yeah, and we have all the admin information, like the disk usage percentage, for example. Yeah, and the key thing I want to show here is on utilities, where you can find the file system UI, and the root path here prompt us to like this path. And in this example, I will demonstrate using our Hadoop user path. Okay. Then the next step is for us to prepare our data and script. So I have already I have some script to run a Spark job, which will process our data in a CSV file here. So the data in CSV is this data, and the script will be this Python script. So this Python script take in two arguments. One is the data source and one is the data output. And what I will do is to use Spark library, PySpark for specific. And what I would do is I will read in the data source, which is a CSV file, create a temp table so that I can run Spark SQL query on it. And then I will run SQL queries to do simple analysis. Right, so I will not go into too much details on the actual analysis. And afterwards, I will just write out the CSV file to some output location. Okay, and the next step for us is to transfer the file from local to our primary cluster, to our primary node. So we can use rsync to do so. I have copied the command here. So I just need to do rsync and paste in the same destination. Yep, I'll do the same thing for the data. Yeah, so we can do a quick check here. So our data and our script is already here. The next step is we will do Hadoop CLI command line to put the data into from local to Hadoop. So using this command, and I'll put it under user Hadoop. Okay, so this copy from local command allow us to copy a file from local file system to Hadoop distributed file system. And the next step is just to verify that the file is already in Hadoop. Yeah, it's already here. And we can do a quick check on the actual directory that store the Hadoop data. Let me do a verification. Sorry. So this command, we will have to SSH into the data node, and then you will find that the data is actually stored inside this MNT directory in the data node. So if you want to check it out, you can directly SSH into the data node. Okay, so the next step is just for us to submit a Spark job, and we will submit it and then double check the application that has been submitted using the Spark history server, where we can find the Spark UI. So the command to submit a Spark job for distributed computing is this Spark submit, where we specify the deploy mode to be cluster, and you can add additional configuration related to how much resources we want to give this Spark job, and Jan will take care of the resource allocation for us. But in this example, I will just use some default config. right? So let us run the Spark submit command, and you will see that there will be some logging. So it shows that our job is being submitted. And to verify this, we can go to Yarn and check submitted or accepted. Wait, give me a moment. Yeah, so accepted. So this application, this Spark application has been accepted by Yarn. It will take up some resources like memory, or like some core. So in this case, we only require one core and like about 2 GB of memory. And after accepted, you will see that it changed to running state. So if you want to view the UI, you can click on this link. You will see the Spark UI. Yeah, and you can check out how much resource this one is using here, or like some other environment configuration. So a Spark job is divided into different jobs, stages, tasks. So you can do more read up on Spark to understand if you want to find out more. You can also see the SQL query here, how it's being translated from our query in our script to actual execution plan that Spark take. And the next thing we can see is if this application already finished and you want to view past application and you want to view the UI or see the logs of past application, you can use the Spark history server. So by clicking on this, you will see that I have submitted one application here at this time, and we can download the event log. And this event log is useful for helping us, helping Spark reconstruct the UI, and we can see the UI even though pretty sure the application has finished here, right? So once the application has finished, it will have also have a link to our Spark history server where all our application event log is stored, and Spark can reconstruct the UI for us to view. Yeah, and going back to Yarn for a little bit. Yeah, after the application is finished, you can see the status here has succeeded, and you can click in to view the logs. Yeah. So you can see that Yarn is our node manager, managing the resources or all the application logs, all those. And lastly, I want to introduce one of the last application that our cluster has, which is Zeppelin. So if you know about interactive shell, you know that it's very helpful for us to do interactive analysis on the data. But in some case, we want kind of a notebook kind of UI, like Jupyter Notebook. We have the same thing for Spark here, called Zeppelin. So using Zeppelin, we can interact with Spark, even using the Spark Scala, and we can also write queries to interactively analyze our data. So let me just create a sample query. So this is how Zeppelin Notebook will look like. And we can do some analysis here, like checking our input data, reading our input data, and another thing is we can verify that our input data has been created from the Hadoop HDFS UI. So just now I've copied the local file here as the data, and we run our Spark job, and we want to output it to an output directory. So once we go there, we will see that Spark has already helped us to analyze or process the data and write output back into HDFS, right? So the next thing we do is to do some analysis on what data we have. Yeah, so we can see that I have some basic data is related to like checking the quality or inspecting the quality of some restaurant to see whether they violate the food standard, and depending on the violation type, you will have some violation points. So our script here is just doing a simple aggregation to count the total number of red violations for each restaurant, right? So the next thing we will do is to read in our output. Yeah, so we can do interactive analysis like this, which is very convenient, and you can use PySpark or Spark Notebook directly. Normally for Python notebook are very popular and widely used, but for Scala we don't have that much option, I believe. So Zeppelin is a very good tool for us. Yeah. So after the aggregation, we can see that all the restaurant with the highest number of red violations sorted by descending order, it has been displayed here. And yeah, so I guess that is all that I want to show you in this video, mainly the setup and how we can interact with the cluster. I hope that this video is useful in some way, and looking forward to making more videos in the future for you guys. Yeah, thank you so much.